right, let's do some more. All right? Here we're doing, what are we doing here? Any number of zeros followed by any number of ones. Right? And what do you have to remember? You're reading them so far. You have to say, well, am I still in the zeros? Right? And then you go, once you go over to 1, you have to remember, oh, I'm in the ones. Right? So this is what we kind of got. We have to say here, well, I know that I've only read 0 so far. Right? And here I know that I've gotten at least 1, 1. Right? Maybe this isn't a good name. Maybe I should call this, you have at least 1, 1. Right? And what happens is you start. Well, where do you start? Well, with the empty string, sometimes it's hard to know where to put the empty string. Right? So you could have the empty string separate. But the empty string, well, it's a block of zeros of length 0, because I'm still in the 0 case, right? I haven't gotten a 1 yet. I've gotten a 1 so far already. Right? And so I read as many zeros. I can read as many zeros as you want. But as soon as I get a 1, I'm over here. Right? And then I can read as many 1s as you want. And if I stop there, then I accept. In fact, here, suppose I have a bunch of zeros and no 1s. Well, that's okay, because I could have 0 1s. Right? So I accept here. But if I get a 1, and then I get a 0 again, then you're dead. Right? Everybody buy that? Yep. Oh, the empty string? Yeah, well, that's what I said. Sometimes you have to think about where the empty string belongs, where my start state is, right? So I might have started by building this saying, what am I going to remember? Oh, I'm going to remember that I'm still in the zeros. So I'm in the state where I'm reading lots of zeros. And then I get a 1. I'm going to go over here and say, now I got a 1. I can read a bunch of 1s, right? And then you have to say, uh-oh. What's the start state, right? And we could have had its own state by itself, which is the empty string. But then I thought, actually it's okay to start right here, right?
Aren't you missing an accept statement? If you hand it a tape with nothing on it.
Then the answer is? No, true, because 0 star contains 0. Well, I'm in here. If I start here, I accept. Right? I mean, that's partly you have to think, well, where do I want to put the start state, the empty state, the start state? And here I think, oh, it seems to belong here, but does it have the right answer? Right? If I'm wanting this to be an accept, then is the empty string an accept? Right? So I have to think, oh, is the empty string special? Does it need its own answer? No, it's not really that special. It's kind of another example of this, and it has the same answer as this, so it don't need its own state. Right? Does that make sense? Yeah. No. No, you could have the string 1, 1, right? Because for the 0 star, you could have 0 zeros. So you start here, you read a 1, you read a 1, you accept. I mean, how you run it is you just get the characters and follow the edges. So when I start, I've read the empty string, and I'm sitting here. If I get a 1, I immediately go here. I get more 1s, I stay here. If I get another 0, I'm dead. Right? Otherwise, maybe I start here, I get a bunch of zeros, and then I get a 1. Right? So that's, everybody understand these machines? Right? I do think, I've been saying that this is a hard course for second year, But on the other hand, I do believe everybody should be able to build these things, right? It's kind of like a flow chart, right? When I first started computer science, they made us do flow charts. Do they do that anymore? And this is kind of like a flow chart where you read the characters and you move from one state to another. Yeah? Yeah, yeah. If it starts, you start here, and if the first character is a 1, then you come over here. Yeah? You mean you always have an empty string. Do you need a state by itself so it's an empty string? I guess is the answer does the empty string have its own personal answer? Or maybe you don't know that, if as soon as you get a 1, you lead in one direction, you get a 0, you lead in another direction, then you need an empty string by itself. All right. So here's another example, right? This is the set of all strings of zeros followed by 1s, except the number of zeros has to equal the number of 1s. Right? How are we doing for time? Anybody know? 5 minutes. See, he's leaving, so I figured it was time. Right? We have 5 minutes. He's not really leaving. He's just putting on his coat. It was cold. But it was good timing anyway. Let me know. It was a good. People should rustle. With his 5-minute warning, I need a 5-minute warning, and you could interrupt me, or you could put on your coat, right? That's how I know that we got 5 minutes. Right? It was perfectly reasonable. Right, exactly. It's always good to have a 5-minute warning. It's just like I'm a 2-year-old, right? Give me a 5-minute warning that we're going to have to leave. All right, so anyway, we got 5 minutes we can do this example, right? So everybody get the problem. It's the same number of zeros as 1s. Right? So how are you going to solve it? You're going to start reading the zeros. And what do you got to remember? You got to remember how many zeros there are. And can you? If it's not yes, then what's the answer? No. Why is it no? Because I only have a finite number of steps. Right? And there's an infinite number of possible zeros. Right? So if I wanted to count, so here, so here's some, what's this? Here's code which is counting. It says I got a 0 block and I'm counting the number of zeros. Here, I don't know, let's not parse it too much, but here I'm counting the number of zeros and then I'm counting the number of 1s. Right? So how many states do I need? I need a different number for every number of states. Right? So here I'm counting the number of zeros. Right? Here I have 0 zeros. Here I have 1 0. I have 2 zeros. I have 3 zeros. Right? But if you want to count arbitrarily high, you need an infinite number of states. Right? And what's the F in DFA? In fact, I asked that question once. What's in the test? And yeah, people did okay on that one. All right, how much time we have? Now we're probably ending, right? 3 minutes. Okay, 3 minutes. Here we can do the same first order logic because you know I love it. Right? Is it true that there exists a DFA that on all inputs can answer this question? And the answer is no. Right? So if one guy comes up with the DFA, then it has some number of states. Right? You give me a DFA, it has a number of states. And if you have a number of states, then, it's a lot of states. But that's no good because I can still come up with a bigger input. Right? So how big is my input? I'm going to make my input to be much, much bigger. Right? I'm going to have a lot more zeros. Right? If you want to count up to n, you're going to need n zeros, which is too many. If you only have k states, you can't count up to past k. Right? But here's the thing. For every k, give me a k. Right? I guess it's saying there exists a k such that for every n, k is bigger. Is this true? Right? There exists a k such for every n, like n is smaller than... No, it's false. Right? Because if I tell you the k, there's going to be a bigger n. Right? So that's the bottom line. So it's not regular. And that's what we're going to say. It's not regular. I don't see you again, right? So have a good week. If you're behind, catch up. But don't kill yourself. Literally. Or figuratively. Let's take the mic off. Yes. Let's finish.